The second way we'll look at representing relations is with a digraph. So a directed graph, also known as a digraph, has a set of vertices, V, along with a set E of ordered pairs, which we call edges. So the A is the initial vertex of an edge AB, and B is the terminal vertex. And any edge of the form AA is represented using an arc from the vertex A back to itself, and this is known as a loop. So for example, here's a digraph. In particular, we have the edges AB, AD, BB, BD, CA, CB, and then DB. So these can be used representing relations. So for example, I want to draw this digraph. So we start realizing that this is 4 points. So we'll have our 4 points, 1, 2, 3, 4. And honestly, it doesn't matter where you put these 4 points. Your graph may look a little bit differently if you order the points differently. However, it will be the equivalent. So we have 1, 2, 1, 3, 2, 2, 2, 3, 2, 4, 3, 1, 3, 4, and 4, 3. In addition, if we're given a graph, we can figure out all the ordered pairs. So for instance, here we have 1, 1. I also have 1, 3, and 1, 4. I have 2, 1, and 2, 4, 3, 2, and 3, 4, and 4, 1, and 4, 4. So here's my list of vertices. So a relation will be reflexive if and only if there's a loop at every vertex in our directed graph. It's symmetric if and only if for every edge between distinct vertices, there will be an edge in the opposite direction. And it's anti-symmetric if and only if there are never two edges in the opposite direction. And then transitive. This happens if whenever there's an edge from X to Y and an edge from Y to Z, we also need an edge from X to Z. So we should have all triangles in the graph with the correct direction. So for example, let's look at this one. All 4 of the points do have loops, so this one is definitely reflexive. It's not symmetric, however, because for instance, we have an arrow going from 2 to 1. However, we're missing this arrow from 1 to 2. It's also not symmetric or not anti-symmetric, since we do have a possible double arrow here in the center. We do have one that goes from 1 to 4 and from 4 to 1, so it's not anti-symmetric. And then finally, we need to look at transitive. In particular, I am missing some triangles. So for instance, I can go from 2 to 1, and then from 1 to 3. So I should be able to go directly from 2 to 3. However, I am missing this edge here. So even though the triangle in this problem does exist, it doesn't follow the correct directions. I need to be able to go from 2 to 1, from 1 to 3, and then I should also be able to go from 2 to 3. And I cannot. We'll look at this one. This one's not reflexive, since you can see I don't have loops everywhere. However, it does have all of the double edges, so it is symmetric. However, not anti-symmetric. However, I'm not transitive. For instance, I can go from 1 to 3, or from 3 to 1, and then from 1 to 4, but I'm missing the way to go between 3 and 4. So I am missing triangles here.